So previously we had talked about the radius of convergence. Now we're going to also talk about the interval of convergence for series that are not geometric. For a geometric series, we learned that, for example, if I give you this is a geometric series. Your r just happens to be x. We know that it will only converge if that r is less than 1. And this is your interval. My radius of convergence would be 1. And we know that neither of these symbols are going to have an equal sign, because when it's equal to 1 for a geometric, it diverges. Now, if it's not a geometric series, we talked about that you have to use the ratio test. But when you use the ratio test and you get to your limit, if the limit is equal to 1, remember it's inconclusive. So after you solve for the inequality for a ratio test, you actually have to check the endpoints separately. Okay, so let's go ahead and come up with the limit first using the ratio test here. So remember, anytime they ask about interval, radius of convergence, really you only have two options. Either it's got to be a geometric series, or you have to set up the ratio test, because that's the only one that it's going to give you an inequality to solve. So let's set up a ratio test. N goes to infinity, n plus first term divided by the nth term. Okay, I'm going to simplify. Notice all you're left with is an x to the first on the top. The n and the n plus 1 are still there. But when I take the limit now, the limit of this is 1. So your limit is just this. This is your ratio test. Ratio test says it converges when that limit is less than 1. So I can go ahead and solve this pretty easily. So just from here, I do know the radius of convergence, which is 1. But this question is asking for the interval. So because we use the ratio test, I don't know exactly what happens at the endpoints. It could converge, it could diverge, so you actually have to check the endpoints separately. Okay, so let's start with the first endpoint 1. So what you're going to do is take your endpoint, and you need to figure out what happens when I plug in 1 for x. Is this going to be a series that converges or diverges? When I plug in 1 for x, I end up with this. Well, 1 to the n over n is just always this. This is a p-series that diverges. Okay, let's try -1 and see what happens. If I plug in -1, again, back into this original series, you end up with this. This is an alternating series. Is it true that the limit of the general term goes to 0 and the n plus first term is less than the n term? Yes, it is. You can also write it like this, that the absolute value of the numbers approach 0. So either way is fine. So because it does, at x equals 1, we can say it converges by the alternating series test. So your interval of convergence is actually this. At -1, it converges. At 1, it's going to diverge. So this is your interval of convergence. So when you are using the ratio test, it's important that you check your endpoints separately. Okay, let's try one more. So again, this is not a geometric, so we can't do that. So we have to start with the ratio test. The n plus first term divided by the nth term. Okay, let me simplify a couple things. Again, all you're left with is an x to the first on the top. These two things don't cancel yet. But when I take the limit, because the degree is the same, the limit is 1, and all you're left with is x. This is my ratio test. Ratio test says it only converge if that limit is less than 1. So again, here's my inequality. If it asked you for the radius of convergence, you would just tell them it's 1 and you're done. If it asks for the interval of convergence, you have to check the endpoints separately. So let's start with x equals 1 again. If I plug in 1 into the original, again, 1 to the n is always going to be just 1, so this is what you have. This is a p-series that converges. Now let's try -1. If I plug in -1 for x, we're going to have to use alternating series test here, and again, it's also true that the absolute value of the numbers decrease to 0, approach 0, get smaller to 0, etc. So this also converges by alternating series test. Your interval of convergence in this problem would be then this. It would be including both endpoints.